This video has been created by Great IT Courses. It's a part of a mathematics course that will teach you mathematics step by step from basic algebra all the way up to calculus. For more information or subscribe to the course, please read the video description. Thank you. So in this video we want to talk about imaginary numbers and I. So let's start from somewhere we are, from some place we are familiar with. Let me tell you a little about radical expressions. For example, let's have a few examples. Let's say you have the principal square root of 4. You know that the principal square root of 4 is equal to 2. And why is that? Why is it 2? In the first course, if you took the first course, basically in the first course we said that by definition the principal square root of, or the principal nth root of a number, when I say the principal nth root of a, this is supposed to be equal to some number b, for example, that when b is raised to the power n gives me a. And also based on the definition of the principal nth root, we said that if you're taking the principal nth root of any real number, then that number, then the resulting number b is supposed to have the same sign as a. So that means that if you're taking the principal nth root of, for example, let's say minus 8, then, or let's say the cube root of minus 8, then you're left with minus 2. That means that minus 2 whole raised to the power 3 is equal to minus 8. And also that also means that minus 2 has the same sign as minus 8. They're both negative numbers. Or if you're taking the square root of 4, the principal square root of 4, this is equal to 2 and not equal to minus 2. Minus 2 cannot be used here, although you could say, for example, minus 2 whole squared is also equal to 4. But since we're taking the principal nth root of 4, that is equal to plus 2. So that was all good, and we had no problems there until we came across some problems where this principal square root definition created some problems for us. And that is, let's say you are basically let's say you are solving some quadratic equation. We have not studied quadratic equation in this course, or in excuse me, in this course or in the previous course yet, but we have studied linear equations, and linear equations are something like quadratic equations. Linear equations, for example, are like 3x plus 2. So 3x plus 2, you can see that the exponent of the variable here, or x, is 1. Now quadratic equations are basically expressions like this, and this is the leading term, and you could call this whole expression a polynomial of degree 1, and the leading term has power 1. And or I could say the variable in the leading term has power 1. Now if you had 3x squared plus, let's say, 2x plus 5, this equation is also a polynomial of degree 2, and as you can see, the the variable in the leading term has exponent 2. And now let's suppose in this case you would say, okay, if I want to solve for x, I would say if I equate this to 0, 3x plus 2 is equal to 0, and then I could say 3x is equal to minus 2 and x is equal to minus 2 by 3. So this is easy. This has only one root because it's a polynomial of the first degree. But this one is a polynomial of the second degree, and so it has two roots. And in order to solve for x here, there are many different ways you could factorize that, or you could do many different things. But one of the easiest and basically best ways to go about solving this polynomials and here solving for x is to use a formula that's called, I don't know what it's called, but here you can solve for x, and here in this equation x is equal to minus b plus or minus root 2 of b squared minus 4ac over 2a. Now here a, b, and c are, this is a basically, this is b, and this is c. So you can substitute and solve for x. Now, so now it looks like our problem is solved, and we can solve for x in our quadratic equation. But sometimes, now the problem is mainly in this area where you have the square root of b squared minus 4ac. Once you substitute these ABC values in this part, and you are essentially basically calculating root 2 of b squared minus 4ac, sometimes the value of b squared minus 4ac becomes less than 0. This whole expression becomes a negative number. Has a negative value. And when this has a negative value, then that means that you're here dealing with some situation, like for example the square root of minus 4. Now here we said that the principal square excuse me. So here we said that the principal square root of plus 4 is equal to 2. And we defined that, and everything was okay here. But the principal square root of minus 4, here if you want to solve this, you have this principal square root of minus 4. And principal square root of minus 4 is equal to some number a, for example, that when you raise that number to the second power, because you have a 2 here, you're supposed to get minus 4. Now if you go for example, if you go for 2 plus 2 whole squared is equal to plus 4. And if you go for minus 2 whole squared is again equal to plus 4. And so there is no way that you can possibly solve this equation. And so, but the roots basically exist in this equation that you are solving here. The roots exist, but you need to find a way to find the roots. Now, let me erase all this. So now the problem is that the problem was that I was trying to solve the square root of minus 4. Now there is one way that you can do this. You can write this as the square root of minus 1 into 4, and then you can separate these two. You can write this as the square root of minus 1 into the square root of 4. Now you know that the square root of 4, you already know it's equal to 2. So this is 2. But the square root of minus 1 is again the same problem. Again, taking the principal square root of a negative real number, which is again the going back to square one. So here, because we want to find a solution to find a way to solve this problem, here we can define that basically we can basically define that the square root of -1, I can call it I, and then I can write this equation as 2i, and now my problem is solved. Well, of course, there is more detail to this, and then what exactly I is and how you can represent it, how it works, how you can represent it geometrically and things like that, we will get to that in this section. But now basically we have found a way to basically to represent something that's seemingly not defined, or there is no answer for it. Now we have find a way to represent it in some accepted way, and that is called that's basically the concept of imaginary numbers. Now here, as you can see, I have defined the square root of -1 as I, and so let me see. So now we have basically we have defined I, and our problem seems to be solved. Now we said that I is an imaginary number. We called it an imaginary number, and well, the difference between a real number, for example +4, and an imaginary number I is that when you have, for example, a +2, a real number, a positive real number, when you square this number, you get a +4. If you have a negative real number, and when you square it, you get a +4. So it doesn't matter whether the real number is negative or positive. If you square any positive or negative real number, you will get a positive real number. But in case of imaginary numbers, it's different in that an imaginary number, when you square it, for example, when you write I squared, that would be, for example, the square root of -1 whole squared, and this is equal to -1. So now this is an imaginary number, and I have squared it, and I have gotten a negative real number. So that's the difference between imaginary and real numbers. Next, what you need to know is that so now you know enough about imaginary numbers. You know the difference between real numbers and imaginary numbers. Now, if you have a real number like 4, and if you add it to an imaginary number like I, so this is the real part, and this is the imaginary part. So if you add a real number to an imaginary number, what you get is basically called a complex number. This is called a complex number. So a complex number is basically a number, an expression, where a real number and an imaginary number have been added together, or you could say a complex number has a real part, has an imaginary part, they've been added together. And that's all there is to this. The only thing here that you need to know, a complex number written in standard form, I suppose, a complex number written in standard form is that you first write the real part a, and then you write the imaginary part bi, and that is the standard form of a complex number. So basically a complex number is a number of the form a plus bi, where a is the real part of the complex number and bi is the imaginary part of the complex number. So here, as you can see, if b is equal to 0, then you're left with a real number. If a is equal to 0, then you're left with bi, and this is called a pure imaginary number, which means that you don't have the real part, so it's called a pure imaginary number. So that's all you need to know here. In the exercises that we have, we will basically do some exercises on the theory that we learned here. Thank you, and I'll see you in the next video.